Hey guys, welcome to video number 2 of our Algebra 1 math course. In this video, like the title card said, we are going to be talking about order of operations. We're going to be learning good old Pemdas. Despite what you may have seen on social media, Pemdas is correct. There's nothing wrong with that acronym. There's a couple of details that we're going to make sure we have ironed out that some people are missing sometimes, which is why all these posts are floating around saying Pemdas is wrong and you learned it wrong and all these other things. So we're going to, dive into these things. That way you too can get the right answers on those stupid Facebook math quiz things. So let's dive on in. All right, so PEMDAS. PEMDAS stands for parentheses. Okay, so that's really any kind of grouping symbols. We're talking about round brackets and square brackets. Even the stately curly brace would fall into this category. So grouping symbols in general, P just it fills in for parentheses. And what we need to know about parentheses and the way to solve them is we go from inside to outside. So the innermost. So and it doesn't really matter. They used to teach that parentheses go inside, and then there's square brackets, and then there's curly brackets. That's not really true, and it's misleading. They can be in any way. We can have nested parentheses. We see that all the time, where you have parentheses, and we've got some junk inside of there, and then you've got some other parentheses on the outside of those, and then maybe square brackets on the outside of that, et cetera, et cetera. And the way we work those out, and the order of those operations, is we go from the innermost, and then we work our way out from there. So that's parentheses, and we work those inside to out. PEMDAS. Exponents is the sound in there. Exponents. Okay, so that's anything that is a power. And again, we work those inside to out as well. So this applies to both of these things. Right? Exponents, if you've learned in my class or a lot of other classes, if you've been doing anything if you've learned order of operations, exponents may be the one that you didn't see in your pre-algebra class. So that's the additional thing. We'll look at how that works with some examples. It's going to be easier to understand. So the next thing is and this is important, and this is the part that some people, all the videos and posts and things of people saying PEMDAS is wrong. This is the first place that they're really talking about. M stands for multiplication. And D stands for division. Okay. Now, what's important here is that multiplication and division are on the same level. So multiplication and division, they're actually probably, possibly, hopefully, maybe, cross our fingers, maybe. You might have learned in pre-algebra that multiplication and division are really the same thing. Division is, just multiplication times a fraction. And so that's why we think of them on the same level. And so we do multiplication and division in the same step. They're the same step. In fact, in our textbook that we use in my class and many other ones, they don't even list PEMDAS because of this misunderstanding. And that is, we do multiplication and division on the same step. Addition and subtraction are going to be the same step too. The way we decide which multiplication and which division to do first, we don't do inside out, because that's for parentheses and exponents. We do left to right. So the leftmost multiplication or division leading all the way to the rightmost multiplication division. And actually, when we look at properties, we can actually rearrange stuff too. So there are plenty of ways where PEMDAS is kind of a lie, but it's helpful to kind of get where we're going. Just like later on, FOIL is kind of a lie too, but that's okay. We sometimes use acronyms to make our brains have to think less, so we can focus on the things that are difficult. So PEMD And then the os is addition and subtraction. And just like multiplication and division are on the same level, addition and subtraction are actually on the same level. So addition, subtraction go on the same level. So there's actually 1, 2, 3, 4 steps, not the 6 that it looks like, right? And that's the 4 is struggling. Let's try again. 4 steps, right? And we do this left to right as well, right? So we do parentheses first, then we do exponents, then we do multiplication, division, then we do addition, subtraction. Now, as we're going to see in some of these examples, sometimes we're going to do exponents before parentheses because there's exponents inside the parentheses, and so that's where the inside out comes. So let's dive into some examples and make sure we understand what we're doing, because that's going to be the easiest way to concrete this concept in our brain. Let's dive in and take a look at some examples. We're going to start with one that's fairly straightforward, doesn't have any grouping symbols, no parentheses. So here's some examples. Example number 1 is 16 minus 8 divided by 2 squared, or 2 to the 2, plus 14. So we walk down that memory for us, parentheses, exponents, Pemdas, right? There's no parentheses, so we're not going to deal with that, but we are going to deal with this exponent. So that's going to be our number 1 step right there. So 2 squared is the first thing we're going to do. So we're going to bring down everything we haven't touched. We're going to get used to doing that a lot this year. If you haven't touched it, bring it down. Make sure your stuff is neat. Make sure it's orderly. Make sure you're using that lined paper. 2 squared, we already said, is 4. Because the neater you can keep it, the easier it'll be to not make those careless mistakes, right? So now let's look and see what we've got next. So there's no more exponents. So is there multiplication, division? Well, yes, there is. So we're going to do this division next. That's going to be the next step that we take care of, is that division thing. So 8 divided by 4 is 2. So we've got 16 minus 2 plus 14. So there's no more parentheses, no more exponents, no more multiplication, division. All we have left is, excuse me, all we have left is addition, subtraction. We deal with that from left to right. So we're going to do 16 minus 2, which is 14. 14, and then plus 14. 14 plus 14 is 28. Easy peasy lemon squeezy. Got that? No big deal. Let's do another example that kicks it up a half a notch or so. All right, let's see. Let me move my thing over. Example number 2. Example number 2 is 4 divided by 2 plus 5 times, if for some reason you haven't seen in your pre-algebra class or any middle school classes you've taken or anything else, that if we have a number right next to parentheses, that means times. That's what that means. I won't all through this course say that because hopefully you'll pick it up as we go. But if for some reason you haven't seen it, that's what that means. So we do have parentheses. We have grouping symbols to deal with. So we're going to deal with everything inside of those first. So the first thing we're going to take care of is what's inside. That 10 minus 6. 10 minus 6 is 4. I'm going to leave the parentheses there. Now it doesn't really mean parentheses. It just means times. But it's going to keep it all neat and organized. You could replace that with a dot, the dot operator, or the X times symbol, or whatever if you prefer, and that's totally fine. So there's no more parentheses, not really. It's because that one's just times. There's no exponent, so multiplication, division, we do have that. we're going to go ahead and take care of these on the same step because they're separated. So we can do 4 divided by 2, and we're also going to take care of 5 times 4. 4 divided by 2 is 2. And 5, times 4 is 20. So there we go. And all we have left is 2 plus 20. So the answer to this example is 22. No big deal at all. Let's kick it up another notch with example number 3. If I put it here, is that going to bug you? If this kind of stuff bugs you, and as we go, since this is only the second video in here, I'm kind of producing this one in a vacuum almost. Without a lot of feedback. But if it bugs you for me to put so many examples on one page, let me know in the comments, or if you're in my class, let me know in class if you want to, or through any of our communication channels or any of those things. And because I can adjust how I'm doing these, and I would not have any problem with that. So do example number 3. We're going to do 6 times. We're going to do times by putting 6 right next to a square bracket. 32. And then minus, we're going to do another parentheses, and 2 plus 3. And then we're going to square that parentheses, and then we're going to close that bracket. All right, we got all kinds of stuff. So we're going to look at parentheses first. We've got this big bracket set that goes together, and we've got this round bracket or parentheses set there. And so we're going to do the innermost one first. So the innermost one we're going to take care of. So we're going to take care of 2 plus 3. And we're going to bring that down. We're going to put it right underneath. Keep it all nice and neat. We're going to bring down the parentheses. See, this is an example where it is really useful to keep that parentheses. It would especially be useful if that 6 happened to be negative or something. Then it would really matter because in this problem, it wouldn't matter. Actually, it would end up being the same. But it could really matter if that was cubed or something. And so sometimes keeping those parentheses until we really, really don't need them anymore can be useful to keep those mistakes from happening. So we're going to deal with this exponent next. Now, I know that we've got more parentheses still, right? But this exponent is inside of that parentheses, and that's what I was talking about. So we got to deal with everything inside of the parentheses before we kind of go out to the parentheses. So even though it's exponents, it's kind of like it's a little sub-problem is kind of the way that works. So we're going to do 6 squared. What is 6 squared? Well, that's 36, right? Minus 32. I made a mistake. It's a lot easier to do these whenever. That's goofy. Were y'all screaming at the screen? Did y'all already hit dislike and ruin my life forever? How about 2 plus 3 is 5? I'm glad I have notes here to make sure I'm on the right track. So this would be 25. Sorry about that. Even I make mistakes. Okay, 32 minus 25 is 7. So 6 times 7. Again, this last one you could probably replace however you wanted to replace. Then 6 times 7 is 42. All right. That's all there is to it. Now we're going to do one more that's going to kind of kick it up a half a notch or so, sort of, because it's going to be a different style of problem because we're going to use the substitution property, right? So did we talk about substitution property in the last lesson in this, or is that my pre-algebra? Was it this one? I don't remember. Nope, it was in pre-algebra. So I talked about substitution property recently, but not in this class. All right. Let's write the example and I'll show you what we mean. So this last example, for example 4, we're going to evaluate. Let me shrink my pen down a little bit. Evaluate 3x squared plus parentheses 2y plus z cubed, yes, cubed, if x equals 4, y equals 5, and z equals 3. Okay, so this is what we mean by substitution property, because what we're going to do is we're going to take and substitute this x in where this x is. We're going to take and substitute this y in where the y is. And then we're going to take and substitute the z in where that z is. So the way I like to do this is I like to rewrite that expression, but with parentheses everywhere where a variable is. Okay? And I like to do that mostly because of negatives. It keeps us from making weird negative mistakes later, especially when we're talking about squaring, raising things to a power and all of that. So 3 times and then squared. So see, instead of an x, we wrote parentheses. That makes sense? If it doesn't, let me know in class or in the comments or whatever else. Times plus 2, and then we're going to put parentheses where the y is, and then plus parentheses where the z is, and then we make sure we put that cubed, and then we close the parentheses. So now, wherever the variable is, we need to look at our little list of things that we're going to substitute. So this one was an x, so we're going to substitute a 4 in for x, right? This one right here was a y, and so we're going to put whatever y was. So we're going to put a 5 in place of that. We're going to substitute it. And this last one was a z, so instead of z, we're going to put a 3. There we go. Now we've got a simple order of operations problem that we've been dealing with this whole time. So we're going to deal with parentheses first. We're going to deal with what's inside the parentheses. Now what's inside the parentheses, we've got an exponent. So we're going to deal with that exponent, right? Excuse me. 3. Sorry, I was looking in some other place. I got confused. 3 cubed is 27. Okay. And now we're going to bring down everything we haven't touched. And then 3 times 4 squared. Make sure we bring down the plus. Right? So we're still inside the parentheses. We're going to deal with that. So we're going to deal with that multiplication inside of there. So 2 times 5. 2 times 5 is 10. Easy peasy lemon squeezy, right? Plus 27. All right, bring down what we haven't touched. 3 and then times 4 squared. We got one more thing to deal with inside the parentheses. That 10 plus 27, which would be 37. We can bring down plus 3 times 4. Oop. Struggling with 4s all of a sudden. Craziness. Squared. Easy peasy. What's 4 squared? 4 times 4 is 16, so it's 16. Because of that multiplication, I'm going to leave that parentheses on there. 3 times 16 plus 37. See, 3 times 16 is 32 plus 16 is 48. Does that sound right to y'all? Let's see if it matches my notes. It does, in fact, match my notes. Is that what y'all got? 3 times 16? 3 times 16 is 48. Plus 37. So the last step that we're going to take care of is 48 plus 37, which is, in fact, 85. So the answer on that example is 85. So that's it for order of operations. If you are in my class, you can find your homework on your homework pages and all of those things. If you are not in my class, remember that our entire Algebra 1 course is available for free, at least a lecture part here on YouTube. So it would really help us out if you'd comment below where this is helpful or not helpful, or any questions you may have, and give us a like on this video and hit that subscribe button. Thank you guys, and have a really wonderful day.